1.6 Equations and Inequalities involving absolute value. Solving equations and inequalities involving absolute value. That's what we're doing. So let's just think about absolute values for a second. All right, so if we said, like, what's the absolute value of 10, we'd say it's 10. If we said, what's the absolute value of negative 10, well, it's still positive 10. So we're saying no matter what, if it's positive or negative, no matter what's in there, it's always going to come out positive. So we're saying that we can have two versions of the number, but it's still just going to come out to be positive. Because absolute value, all it is how far away is this number from 0. That's all. So if it's negative 100, it's still 100 spaces away from 0. And if it's positive 100, it's still 100 spaces away from 0. That's why it's called absolute value, meaning no matter what direction it's going, how far is it from 0, which is the center of the number line. So that's all this theorem is saying, is that when we have an absolute value, we have possibly two outcomes, meaning no matter what you put in, it can be positive, it can be negative. That's what this is stating. So it can either be a positive or it can be a negative outcome. So when we're trying to solve for a variable, when we have absolute values, we need to have a negative version and a positive version. So what do I mean by that? Is when we're looking at this part right here, do you notice the absolute value symbols? They went away and we're just left with inside equals positive and inside equals negative. So that's what we're going to do. We're going to have two equations. We have 5x equals 15, so inside equals positive, and then we'll have inside equals negative. So what we're going to do in order to use our theorem and solve absolute values, we're going to have always two equations. When we have a variable inside, we always have two equations. One that is exactly what it is without the bars. Do you notice it's exactly what it is without the bars, without the absolute value? And then the second one is we're going to change the sign of whatever it equals. Before we can do this, the one thing that we need to make sure of is you need to isolate the absolute value. So absolute value. You need to get it by itself. So here, the absolute value, there's nothing to the left or right of it, so it is by itself. Now we're just going to solve. So we solve like we solve anything else. We're going to divide by 5. And when we do, we get x equals 3. And then same thing here, we're going to divide by 5. So we get x equals negative 3. And that is our solution. We got negative 3 and positive 3. And because we have multiple solutions, we need to write a solution set. That's why we put the little braces or squigglies. Plug it back in your head, it doesn't hurt to try. So 5 times negative 3, that's negative 15. Absolute value of negative 15 is 15. Awesome. If we plug in 3 here, right, 5 times 3 is 15. Absolute value of 15 is 15. Awesome. You should always kind of mentally check your work, make sure it makes sense before you continue on. Alrighty, part B. So we need to isolate the absolute value. What do I mean by that? You see how there's this negative 3 here? We have to make sure it goes away. We only need absolute value equals whatever. So the absolute value needs to be by itself. So we're going to add 3 to both sides. And when we do, we're left with 3 minus 8t equals 11 plus 3, which is 14. And now that we isolated the absolute value, we're going to go ahead and split it into two equations. So this is where I highly suggest, so through the semester, I want you, I might say it, I might not say it, it just depends. I want you to pause videos and see if you can do it. And if you can, awesome, that is so great. And if you can't, you're going to learn better that way, because you're going to be like, oh, I forgot the negative, or I forgot to add 3, or I forgot to do this. It's little mistakes that we usually make. So I highly suggest, for part B, pause it. If you get stuck, look at part A. Now we're going to really just copy part A, but with different numbers. So pause it, go ahead, try it. Okay, I hope you paused it. And if you didn't, that's okay too. If you're like, I'm not ready to try this on my own, that's okay, that's fine too. But I'm hoping you will. Like, just go out and try it. It's okay if you get it wrong, that's fine, totally fine. Alright, so now let's break it up into two equations. Our first one is exactly the way it looks without the bars. So we'll have 3 minus 8t equals 14. And then the second one, it's almost the same, except we're going to switch the sign after the equals. So we'll have 3 minus 8t equals negative 14. Now from here, we just solve for the variable, which we're really good at. So we're going to subtract 3 to both sides. And when we do, we're left with negative 8t equals 11. We're going to divide by negative 8. And when we do, we're left with t equals negative 11 over 8. It does not matter where you put the negative. The negative can go top, bottom, or middle. I'll explain that more as we go through this semester. Alright, so with our orange one, with our negative one, we're going to do the same exact steps. So we're going to subtract 3 to both sides. So I kind of like this. You're just doing the same steps twice. So we have negative 8t equals negative 14 minus 3. That's negative 17. We're going to divide by negative 8. So now we have t equals, so negative and negative become positive, 17 over 8. So we have our two solutions. I'm going to put them up on top in white. So our two solutions are negative 11 over 8 and 17 over 8. Now, numerical order for sets, you don't have to put it in numerical order, but it's like something we like to see. We like to see things in order, but you don't have to, but you should. Are decimals okay? Not unless it says it is. So on your homework, in that little blue text, it'll say how to write your answer. Unless it says to round, approximate, or use decimals, you need to keep it as a fraction. Alrighty. Moving on to C. So part C is going to be a little bit different because I don't know if you caught this. I said it, and I don't know if you caught it, but we only do the steps if the variable is inside the absolute value. So if we look at part C, the variable is not inside the absolute value. What if you forget that? Doesn't matter. We can still get you to the answer. So let's just simplify, because aren't we supposed to isolate the radical or the absolute value? But don't I know the absolute value of 2? What is the absolute value of 2? It's 2, right? The absolute value of 2 is 2. So I can simplify that. So I'm going to, because I can. So we have 2x equals negative 16. The absolute value has gone away. It does, because I can simplify the 2. So we're going to solve for x. We're going to divide by 2. So we get x equals negative 8. So just something different to throw at you, that there is no variable inside the absolute value. So simplify. I know the absolute value of 2. The absolute value of 2 is 2. So I'm going to do that. Now I can solve because it's gone away. The absolute values go away. Alrighty, part D. So we do have a variable inside the absolute values. That means we need to isolate the absolute value. So we need to get rid of the fraction. To get rid of the fraction, I'm going to multiply by the reciprocal. So I'm going to multiply everything by 4 over 1. We should know that that just cancels out that fraction. So we're left with the absolute value of u minus 7 equals negative 1/2 times 4 over 1. So what's half of 4? 2. So negative 2. Alright, so now we're left with the absolute value of u minus 7 equals negative 2. We're talking about absolute values here. Just think about that for a second. We're talking about absolute values. If we're talking about absolute values, don't absolute values always equal a positive number? So don't absolute values always equal a positive number? if that's the case, how is it going to equal -2? Think about that. You're like, but no matter what, isn't it supposed to equal a positive number? So then how can it equal a negative number? That's because it can't. There's actually no solution. It can't. It can never equal a negative number. So I'm actually going to write that out. Absolute values, when they're isolated, so absolute values when isolated cannot equal a negative number. So since it cannot equal, we actually say this is no solution. You can't solve it. There's no such thing to solve this, so it doesn't exist. And that's it. We keep moving on. Something about me. I'm going to trick you sometimes. I'm going to put stuff like that on the test. Part D, you know it's going to be on the test. Also, Part C, those are the little tricks I'm going to try and throw at you. But they're important to know because then you know what an absolute value is. If Part D, if that makes sense, you're like, I get this because absolute values can never equal a negative number. So if that can never happen, it's no solution. Okay. Alrighty, Part E. So Part E, don't worry, I didn't put this on the test. It looks crazy, right? You're like, oh my gosh, there's absolute values everywhere. We have a whole bunch of stuff going on. That's okay. We're still just gonna work our way through this. So we have variable inside absolute value. Since that's the case, we're just gonna treat it how we've always been treating it. The first one looks exactly the way it is, just no bars. So we have 4x squared plus 12x equals 4x squared minus 5x. So the first one is exactly the way it is, no bars. Just like Part A. The first one is exactly the way it's written, just no bars. And that's what we did. Now the second one, the left side takes the stays the same, so we keep it the same, no bars, and the second one becomes negative. But since the second one is a binomial, it's multiple terms, we need to make the whole thing negative. So the whole right side becomes negative. Now, we've been doing that. See, this whole right side, it became negative. There's just one thing to become negative, so we don't need to account for multiple things. That's why for E, we need to account that we have multiple things on the right side, but the whole right side becomes negative. And from here, we just solve it. So if that's still stumping you, rewind and listen to that whole explanation again. All right, let's solve for x. So to solve for x, I'm going to subtract 4x squared to both sides. And thankfully, they cancel each other out. Don't have to work with that. Now we're left with 12x, oops, wrong color, 12x equals negative 5x. We're going to, I guess, divide by x. Whenever you have x's on both sides and nothing else, x is always 0. X is always 0. All right, now let's do our second one. So for our second one, we need to distribute the negative to the binomial. So we'll have 4x squared plus 12x equals negative 4x squared plus 5x. Let's solve for x. I'm going to add 4x squared to both sides. Now I do that just because I want x's to be put together. There's also another reason why I'm doing that, but I'll tell you in a second. Alright, so we simplify to get 8x squared plus 12x equals 5x. So another reason why I'm moving the x squared over, anytime we have, let me get a different color. Anytime we have a squared and only squared, nothing higher, no cubed, no fourth, no fifth, no sixth, nothing. When 2 is the highest exponent, remember that's called a quadratic. What's special about a quadratic, we will get into that, I promise, but for this section, what's special about quadratics, you want the equation to equal 0. So what that kind of looks like, you want it to be ax squared plus bx plus c equals 0. So you want the equation to equal 0 when you have a quadratic. Remember, quadratic is when you have the little 2, the squared. That tells you it's a quadratic. So since I know I have a quadratic, I want everything to equal 0, so I'm going to subtract 5x to both sides. And the only reason why I know to do that is because I have a quadratic. So we have 8x squared plus 7x equals 0. This is a binomial, and the only way to simplify a binomial is look for a GCF, unless it's a difference of squares, but this isn't. So the greatest common factor that they have is just an x. So I'm going to take it out. When we take x out of 8x squared, we're left with 8x. And when we take x out of 7x, we're just left with 7, and that equals 0. So now we separate each factor. We have x equals 0. And then we have 8x plus 7 equals 0. So we're going to subtract 7 to both sides. So we have 8x equals negative 7. You know how to divide. If you don't, we need to talk. So we have negative 7 over 8. And they share the 0. That's fine. We don't write it twice, though. We don't write anything twice in math unless it's very explicitly said to, but it's hardly ever. So we have negative 7 over 8 and 0. That is our solution set. And we also have two numbers. You want to know why we have two numbers? Because we have a quadratic. Because of the 2. All right, it all makes sense. It does, I promise. All right. Inequalities, dealing absolute values and inequalities. So basically it's the same thing. We're going to do very, very similar things. The theorems are here for you. I kind of talk about them as we go along, but these theorems are kind of chunky, so I really don't like to explicitly read them to you. A little note, for your homework, for your My Math at homework for 1.6, choose infinite solutions if there is a solution. Do not pick the finite solution option. So if you do have a solution, choose infinite solutions and then type in your answer. Do not choose finite. There is not a finite amount of solution for this. Okay, so just pretend that there's no inequality sign. Pretend it's an equal sign. So let's do what we did with an equal sign. So let's solve this, and we are going to graph the solution set. So the first thing we did when we had absolute value, so we have absolute value 1 minus 4x minus 9 is less than negative 6. Didn't we isolate it? Yeah, so that's the first thing we're going to do here. We're going to add 9 to both sides. So when we do, we have absolute value of 1 minus 4x is less than 3. Alright, now we're going to separate this into two equations. The first one is exactly the way it is. So 1 minus 4x is less than 3. The second one, we just change the signs to the right. So what do I mean by that? We're going to change these signs. The reason why we don't change the sign here, because can I change the equal sign? No, I can't flip it. See, I flipped it. You just can't tell. I did, but it doesn't look different. But here with it, inequality, when I flip it, it does look different. So I flip it and change the sign. So I change the signs to the right this time. So we treat them almost identically, which is great. Now let's solve for x. So I'm going to subtract 1 to both sides, and when we do, we have negative 4x is less than 2. We're going to divide by negative 4. We divided by a negative, so we need to flip that sign. And 2 divided by negative 4 is negative 1/2. We're going to do the same thing to the orange, so we're going to subtract 1 to both sides. And when we do, we're left with negative 4x is greater than negative 4. Divide by negative 4 to both sides. And when we do, since we divided by a negative, we have to flip the sign, so we get x is less than 1. Now let's graph our solution set. So to graph our solution set, we're going to draw our number line. And we have our two numbers, -1/2 and 1. Put them in numerical order because this is a number line. And -1/2, the arrow is pointing to the right. So if I drew an arrow right there, you see how it's pointing to the right? So the arrow is pointing to the right. That means I'm going to point this to the right. The 1 arrow is pointing to the left, so I'm going to point it to the left. The parentheses, the brackets, that all comes from 1.5. So if you didn't review those notes, review those notes. So our solution set, since they go together, is parenthesis -1/2, 1. Part B. Alright, so part B, we have to isolate the absolute value, so I'm going to add 2 to both sides. And when we do, we're left with absolute value of 9 minus 2x is greater than 13. Now we're going to split it up. So this is where I want you to pause the video and see if you can just solve it. Don't graph it. Don't give me the solution. Don't give me interval notation yet. Just solve it. Give me 2 values. Okay. I hope you paused it. Let's do it together. So our first one, everything is the same. Nothing changes. Our second one, only the outside changes. So we have 9 minus 2x is less than -13. Remember, only the outside changes. So for our first one, we're going to subtract 9 to both sides, and when we do, we're left with -2x is greater than 13 minus 9, which is 4. We're going to divide by -2, and when we do, we get x is greater than, my bad, we divided by a negative, is less than -2. Same thing to the orange side, we're going to subtract 9 to both sides. And when we do, we get -2x is less than -22. Divide by -2. So we get x is greater than 11 because we changed the sign. Now, let's go ahead and plot this on our number line. So numerical order, so we have -2 and 11. So -2, the arrow is pointing to the left. So parenthesis, arrow pointing to the left. 11, the arrow is pointing to the right. So we're going to go point the arrow to the right. So to write this in interval notation, for our first one, the left, that's -infinity. So this is -infinity and this is +infinity. So if it's going to the left, it's going to -infinity and it stops at -2. This right here, the break means union. So this break right here, that means union. Then it picks up again at parenthesis 11 and it's going to the right, which is +infinity. In set notation, so set notation, we would have squiggly, which is called a brace, x such that x is less than or equal, just less than -2, comma, x is greater than 11. For part A, our set notation would be x such that since we have a compound inequality, remember compound inequality is always going to be less than x less than, if it has a line underneath, that's for you to decide if it's a bracket or not. Smallest number first, then bigger number. Again, this is from 1.5. Alrighty, put T. We have to isolate the absolute values. So we have absolute value of negative 5x plus the absolute value of negative 8 is less than or equal to 4. Hold up. Wait a minute. Don't we know the absolute value of negative 8? Yep. And yes, I was quoting that song. You know if you know. Alright. So let's simplify. We have absolute value of negative 5x. And then the absolute value of negative 8, that's just positive 8. Is less than or equal to 4. Now we need to isolate the absolute value, so we're going to subtract 8. And when we do, we have absolute value of negative 5x less than or equal to negative 4. Okay, I hope like alarm bells are ringing in your head. You're like, this looks familiar, but I can't pin it. Let me show you. Let me show you like why you're like, this feels familiar. I'll tell you what. Come on, buddy. Remember this? I hope that's what like your gut was like trying to tell you, like something's wrong here. This isn't supposed to be. You're absolutely right, because we're talking about absolute values. It doesn't matter that it's a less than or a greater or a less than or equal to or less than. It doesn't matter that it's inequalities. We're still talking about absolute values. So remember, absolute values always produce positive values, positive numbers. So since that's the case, are we going to ever have an absolute value that is less than negative 4? Nope, because that doesn't exist. So that means this is no solution. So this is not on the notes, this is something I want to add in right here. If you say you have absolute value is less than 0, that does have a solution. You can solve this. You can solve that. Alright. Moving on. Alright, so the absolute values everywhere, that's okay. Let's just do what we can. So we can simplify the absolute value of negative 11. So we have absolute value of negative 3x is greater than 11. Now we're going to break it into 2. So I want you to pause it, try this on your own. I want you to actually like graph it and do the solution in interval notation. Alright, so let's go ahead and do this together. I hope you paused it though. If you didn't, I really want you to. It's okay if you didn't, it's okay, but I really want you to. Alright, let's do this. So first one, exactly the way it looks, no bars. So negative 3x is greater than 11. Second one, the left side doesn't change. So negative 3x, only the right side changes. So we have less than negative 11. Now let's solve for x. So we're going to subtract negative 3 to both sides. And when we do, so we divided by I meant divide by negative 3. You know what I meant. We're going to divide by negative 3. And since we divided by a negative, we have to flip that sign. And same thing on the right side. We're going to divide by a negative 3. And don't forget, because we divided by a negative, we have to flip the sign. Alright, so let's go ahead and graph our solution set. We have numerical order, negative 11 over 3. And positive 11 over 3. So for negative 11 over 3, the arrow is pointing to the left. So that means the arrow is pointing to the left. For positive 11 over 3, the arrow is pointing to the right. So the arrow points to the right. That means in interval notation, we have negative infinity, negative 11 over 3, union, 11 over 3, infinity. In set notation, it would be x such that x is less than negative 11 over 3, comma, you could also put or, same thing, x is greater than 11 over 3. If you can't draw those braces or those squigglies, that's okay. You notice I'm not that good at it either, although I'm not going to say that one is really good. That's a good brace. So a student taught me, you know those like little stick birds you draw? Just draw it sideways. You know those stick birds, and you draw them in your, like, you drew houses as a kid, but draw it sideways on your paper. Or what I like to see, it's totally fine. That. I know what you mean. Just draw me a squiggly line, literally, that looks like it. I know what you mean, okay? Okay, so, part E. Let's isolate. So we're going to divide by 4. And when we do, we have absolute value of 7x is greater than or equal to negative 1. You're like, there's a negative again. This is no solution. Kinda. It's a special equation. I'll give you that. It's special. But it's not no solution. So no matter what, isn't absolute value always going to produce a positive number? Isn't it always going to give me a positive number? So isn't it always going to be greater than a negative number? It is. I'll write that out. Do not worry. So regardless, the absolute value will give, the absolute value will give a positive value. Every solution will be greater than negative 1. So how we say every solution in math, we say negative infinity to positive infinity, or infinite solutions. Or we can say, see, I suck at those, x such that x is any real number. Hate it. It is the bane of my existence as a math person to not be able to draw those braces. I swear to you, my mom, she was able to draw those braces just perfectly. Like it was typed out. I was always so jealous of that. So all real number is infinite solution, x such that x is any real number. That just means it will always be greater. Every solution will be greater. Those are 3 ways you can write your answer. To graph it, it would literally just be a line on top of the number line, meaning it's going to negative infinity forever and it's going to positive infinity forever.